Alright, Jared is working on his stepdad's truck. This is a truck he just purchased, and unfortunately, within the first couple days of driving it, it threw a P0871 code, which is an overdrive pressure switch rationality code. Normally when that happens, the diagnostic, from what we've seen, is often the problem in the solenoid switch valve of the valve body. We can clear the code, drive the truck nice and easy, and it shifts all through the gears, it holds all the power, but then randomly after about 15 minutes of driving, it populates the code back up. If you keep driving it puts it in 4th gear limp mode, and you cannot keep driving the truck or else you'll do damage to the transmission. So we're going to try to fix this problem. Jared is going to go ahead and pull the valve body out of it, and then we're going to take the valve body over to the bench and use a vacuum tester to where we can actually vacuum test the solenoid switch valve and confirm that it is in fact the problem. And if that's the problem, then we will bore it to a larger size valve and do a built high pressure valve body, and we'll go through those details on the bench with you guys. But we thought we would just walk you through this process. If you guys have a higher mile, this truck has 145,000 miles, so if you're getting higher miles on your 68 and you're having some codes and limp mode problems, if you catch this soon enough, sometimes a valve body can fix your problem without a transmission rebuild. Okay, you can see Jared is doing a fine job of getting the pan off, and it is quite frustrating because Dodge does not put a drain plug, so you have to kind of tip it down. It's hard to do this without making a mess. There's 2 filters on the 68 RFE. There's your filter that goes on the bottom side of the valve body, and then there's also a spin-on filter. These spin-on filters, we always use a Mopar filter. The aftermarkets, we've had problems with them coming loose. And also, if you lose lockup, we've seen drop these pans where you think you have a failed transmission and the filter is laying in the pan. So sometimes just checking the spin-on filter is worth dropping the pan and making sure that that's not your problem. But now he's going to disconnect the electronics, which is the main plug, and then there's the valve body bolts. You have to remove this lower filter and the valve body bolts, and the valve body is going to be able to come down, and we'll take that over to the bench. So to pull the valve body, you need a T25 Torx to pull the filter, and then there's 5 8mm head bolts all around the valve body. You can see the T25s, don't pull those because that actually separates the whole valve body. But the 8mm bolts around the outside right here, the valve body's loose, and the only thing that's holding on to it is where the linkage, or where the electronics go up through the case. So you'll reach up and hold the valve body and push down on the electronics, and the valve body will drop out. And there you have the valve body. So see where this shift linkage is? You want to make sure that when this valve body goes back in, if you're pulling your own valve body and putting it back in, if this shift linkage isn't in the same position, then when you push it up, you can actually break off the linkage arm in the valve body, or in the transmission itself. And the only way to replace that is to completely disassemble the transmission to change that linkage arm. So make sure you do not break that little pin off, or else you're going to have a bad time. Okay, here we have the 68 valve body all torn apart, and this is all clean, ready to go back to what we call a high pressure valve body. And this addresses a lot of our common failure problems. The solenoid switch valve, like we talked about earlier, you'll be able to see the stock switch valve versus the oversized switch valve. We're actually going to bore this 15th thou over, make it a larger bore, use a larger valve. Now we can get it to seal up again. And then to fix that problem and keep that from happening again, D&J makes this billet channel plate here. It's a full billet piece and has about a 1/2 inch thick of billet aluminum that reinforces the valve body and keeps it from deflecting at high pressure. And what happens is under high pressure, the old lower plate is just a cast that's it's 1/8 inch thick at places and will actually deflect. And in the deflection process, it actually wears out that solenoid switch valve. As that valve goes back and forth, there's deflection in it. And now the billet channel plate keeps that problem from happening again because it keeps the valve body nice and flat. Sonics also makes these billet accumulators, and you can see these 2 sealing rings. This keeps this accumulator from being cocked in the bore. The stock ones look like this, and you can see they have moved this actual sealing ring location here to where when this accumulator has gone back and forth in its bore for 200,000 miles and now has created a wear pattern in the bore, then a Sonic's accumulator will now seal at a new area, and you can still reuse the same valve body without replacing it. Okay, the next modification that we do is put a bonded separator plate in. The factory separator plate is just a steel plate, so you have steel with aluminum channels sealing against each other. This actually has a gasket on both sides, and that prevents cross-leaking from one passage to the other. As we increase line pressure in these valve bodies to get more holding power, it's more important that we don't get any cross-leaking, because sometimes in the aftermarket we fix one problem, then we create another. So we're trying to address all the common failure areas with this valve body. And then this is the solenoid pack. We put a new Mopar solenoid pack in all the valve bodies. This has 7 different solenoids in it that controls all your transmissions. It's very important that all your electronics work correctly. Okay, so we're going to start with modifying the valve body for the heavy duty accumulator plate.
Correct.
These 3 holes right here will drill and tap, and that will prevent this plate from being able to strip these threads out and blow out when you have higher line pressure. So these 2 you actually drill all the way through, because you can see there's nothing on the back side, but this one you can see the bit starts poking out the back, so you just get it deep enough that we can get the shoulder of the bolt all the way seated in the valve body. So now we just got the holes drilled. He's going to get a tap. What are the threads on that tap?
5 by 0.8.
5 by 0.8?
Yeah.
We'll tap those holes, and then we'll be able to clean this back up to make sure there's no shavings and start assembly. Got those holes drilled and tapped. Now we're going to vacuum test the solenoid switch valve. Here we're putting the stock solenoid switch valve in its bore, and it's important that the valve body is very clean and dry for this test, because if you have fluid in it, it can give you a false vacuum reading, because this shows how many inch-pounds of vacuum we can hold within that bore.
Just going to calibrate.
Now we know that when the seal is, or the valve is 100% sealed, we have 25 inch-pounds of mercury. And this is a channel. You can see here, this is a little rubber seal, and we can actually seal off an individual channel in the valve body. (15 inch-pounds).
There's our problem.
Alright, so there you're seeing almost no vacuum in that bore. Anything 15 inch-pounds and above is an acceptable range. So anything below 15 inch-pounds of mercury fails the test. So we know that we have a leak here in this channel, and that's why we're going to remove this stock valve for this oversize and put the oversized valve in the solenoid switch valve, and that should fix our problem. Here you can see the jig that we use for boring the valve body, clamping it down, and then we have boring tools that go in here, and we can ream that valve or ream that bore oversized for the larger valve. Really important that you get all the shavings out, because all it takes is one little aluminum shaving and you have a problem. So this is now the new oversized solenoid switch valve, and we'll put this in and then we'll double check the vacuum seal to make sure that we've effectively fixed the problem. There you can see every circuit is well over 15 inch-pounds of mercury. So we are good to go. Next, we have to drive these roll pins in a little bit further to accommodate for the D&J billet panel plate. So here we have a custom sizing tool that we've made, but we just basically are sizing the sealing rings on here where we make sure we don't roll the seals when we install them. Here you can see it's important to have assembly glue on it, and you have to be really careful or else you can pinch the seals as you install them. Something that's pretty simple when you do it every day, but if it's your first time doing it, it can be a little tricky. So the worst part about a valve body is all these pieces are expensive and then you never get to see it again. But if everything works good, it's well worth it. Now Doubles is going to put the 125,000 bolts back in it, and then we'll be ready to final assemble this thing and put it back in the truck. How many bolts are in the valve body, Doubles?
50.
50.
Plus 2.
That's a lot of bolts. These are the rubber gaskets that we always replace, because this goes up and mates up against the transmission, and if you leave those rubber gaskets out or you have one of these torn, and then you will be bleeding off all your pressure coming from your valve body to your clutch pack, and you'll have a premature failure. But that valve body is ready for action.
Here you go, sir.
Thank you, Let's go put that thing in. Yeah, because success. Okay, Jared's got the pan back on and is almost wrapped up with this. We're going to get it down on the ground and top it off with fluid and go for a test drive. So we definitely found a problem in the solenoid switch valve. I feel confident that that's going to fix the problem, but until it's on the road and we've driven around the block and put 15-20 miles on it, we won't know for certain. So we're going to put some miles on it before we turn this back over to Jared's stepdad, and hopefully this was a informative video for you guys. If you've got some high mileage 68 RFEs, you can prevent a potential clutch problem by fixing a solenoid switch valve leak before it ever happens, and that's why doing a valve body is beneficial even if you don't have any problems, because if you're getting over 140,000 miles like this truck had, this is a 2017, then you could already be having problems that haven't coded yet. If you're planning to run more line pressure and add power to your trucks, this is a great modification to do to start the process of long 68 RFE life.